Hello my dears, very good morning to all. So in the last class we discussed about the transformer equivalent circuit. How can we convert a certain parameter, resistance or reactance in primary to secondary or secondary to primary, or in other words high voltage side to low voltage or low voltage side to high voltage. Okay, and today we are discussing a very important session which is nothing but voltage regulation of a transformer. You heard the term voltage regulation, right? You heard, of course, you heard that word, voltage regulation. The voltage regulation of a transformer, let it be VR, is represented like VNL minus VFL divided by VFL. Or in other words, percentage voltage regulation is equal to VNL minus VFL divided by VFL into 100. So what is the real or physical meaning of the word voltage regulation? Let's do this. Transformer also considered as an electrical circuit, right? Suppose this is the secondary. This is a secondary. Consider only the secondary section. Definitely there will be some resistance and reactance, we know that, and this is the load, okay, and across the load, right, there will be voltage V, okay, and the induced voltage here is nothing but E. Of course in the secondary there will be an increased voltage E, and there will be a secondary voltage, load voltage V, and Z is nothing but the load impedance. This is nothing but R2 or JX2, simply R2 JX2. And there is of course a current which is flowing in the circuit, which is nothing but I2. So nothing but I2. So if there is no load means, suppose you imagine a condition, if there is no load, there is no load. Is there is any current? If it is no load, no. There will be I2 equal to what? 0. So I2 equal to 0 means the E will be available. Suppose you measure the voltage, terminal voltage with a voltmeter in your hand. If you measure along these two terminal, definitely you will feel a voltage of E along the voltmeter, right? Am I correct? That is the condition of no load. That means the whole voltage induced in the secondary will be available across the terminal or load side. Okay, so ENL or no load voltage is nothing but what? Here it is nothing but E. But when you connect a load Z here, what happens? There is a flow of I2 in the circuit. So due to the flow of I2 in the circuit, there will be a drop I2 into R2 across R. There will be a drop I2 into JX2 across reactive element. So there will be a total drop of I2 into R2 plus I2 into X2, JX2 drop, right? So from E, the drop minus remaining V will be the terminal voltage, right? From E, there will be the loss and the remaining voltage is available across the load. So we can say that the load voltage now reduced as V. Reduced as what? V. So the difference in voltage with respect to the load voltage, simply that is the regulation. So regulation is nothing but VNL, that is no load voltage, minus full load voltage, that means maximum load voltage, right? Maximum load voltage divided by full load voltage into 100. That is the percentage voltage regulation. So if it is a very good system, if it is a very good power system, then the load voltage, right? Load voltage, whenever we increasing the load, if a good system means the terminal voltage doesn't alter too much with respect to this E, then only we can say that the system is a very good system. If the voltage is very from E by a large extent means there is a large drop in the this transmission. During its transmission there is a large drop. In case of power system we can use the word perfectly transmission. So if you send a voltage and if you somewhere it is receiving, if the transmission line carries too much losses, and what happens? The voltage that we sent doesn't get there. It dropped somewhere. It is in transmission. So it is not a good system. So if a good system means the value of R2 and GX2 adjusted in such a manner that there will not be appreciable change in voltage across the load with respect to the sending end voltage or the no load voltage, then only we can say that it's a perfect system, it's a very good system. So for an ideal system, voltage regulation will be what? For ideal system, voltage regulation will be what? 0. That means VNL and VFL are same for ideal system. That's a perfect condition. It's ideal. We can't make E and V equal in practical system because we are not sending the signal through air, right? Even though air there is losses, right? Even though optical fiber also a small amount of losses will be there. But when then the case of transmission line or conductor, of course there will be some losses. So due to this loss is actually the reason for the dip in voltage. That is the meaning of what? Regulation. That is the meaning of regulation. So in a transformer, the equivalent circuit of a transformer is nothing but this is R equivalent J into X equivalent, right? R equivalent plus J into X equivalent, or R equivalent dash plus J into X equivalent. So you can use any word. Let be RE1. Okay, it's a fine word, right? RE1 or J into XE1. RE1 plus J into XE1, which is nothing but what? Equivalent resistance referred to primary, equivalent reactance referred to what? Primary. So this RE1 is nothing but R1 plus R2 dash. XE1 is nothing but X1 plus X2 dash, because we are referring it to primary, right? So this voltage is nothing but V2 dash, because V2 is transferred to primary, right? And this current is I1, which is nothing but I2 dash, and this is nothing but V. This is nothing, or simply V1. So in terms of this equivalent circuit of a transformer, we can say that voltage regulation is nothing but V1 minus V2 dash divided by V2 dash. V1 minus V2 dash divided by V2 dash. Okay, and we can say that okay, that's all about the V1 minus V2 dash divided by V2 dash. Okay, and there is also another equation for voltage drop in a transformer. I mean a regulation of a transformer. This is one equation for regulation. There is another equation for regulation in a transformer, and this is nothing but VR is equal to I1 into RE1 cos phi plus or minus I1 into XE1 sin phi, or simply phi 2 sin phi 2 whole divided by V2 dash. There is another excellent equation for, actually there is a derivation, but we don't want that derivation. We just need the equation I1 into RE1 cos phi 2 plus or minus I1 into XE1 sin phi 2 whole divided by V2 dash is another equation for voltage regulation, where phi 2 is nothing but the load angle, or the angle between V2 and I2 simply, and I1 you know the current here, primary current, or equal to I2 dash. RE1 you know this, RE1 is equivalent resistance referred to primary and secondary. And see what is the, okay, I am going to represent in with respect to per unit quantities. I will give you a very brief idea of per unit system. Per unit is nothing but actual value divided by actual value divided by base value. That is the meaning of per unit system. How can we represent these equations in per unit system? Because it is very easy to solve a problem if it is in per unit quantities. Two step is just one step answer you will get. We will definitely do some problem. Definitely you will understand the importance of that per unit system. Okay, so let's now going to discuss these equations in per unit system. Okay, these are the two equations which governs the voltage regulation. So we are going to represent in per unit quantities. See here, first take this equation. VR is equal to, what is that? V1 minus V2 dash whole divided by V2 dash. Correct? Which is nothing but V1 by V2 dash minus 1. V1 by V2 dash minus 1. This V1 is nothing but the sending end voltage or terminal voltage. V2 dash the receiving end voltage, right? So if you take V1 is as the actual value and V2 dash is the base value, then this numerator by denominator will change it into per unit voltage. Per unit voltage minus 1 will be the equation for voltage regulation. So if you have per unit voltage in your hand in a question, if you simply per unit voltage minus 1 will give the regulation of the system. See how much easy it is. And one more, there is equation VR which is equal to this. See, I am splitting this term by I1 into RE1 cos phi 2 divided by V2 dash plus I1 into, so plus or minus, right? So plus or minus I1 into XE1 sin phi 2 whole divided by V2 dash. Okay, this is my equation, and this is nothing but, listen carefully, RE1 divided by V2 dash by I1 cos phi 2 plus or minus XE1 divided by V2 dash by I1 A1 sin phi 2, right? This I1 can be taken as denominator. Okay, so what is V2 dash by I1? It is nothing but impedance. Cos phi 2 RE1 by Z cos phi 2 plus or minus XE1 by Z sin phi 2. Correct? Correct. Is it clear? RE1 by Z cos phi 2 plus XE1 by Z sin phi 2. Can I remove this? Can I remove this? So we have VR is equal to what, my dears? RE1 by Z cos phi 2 plus or minus XE1 by Z sin phi 2. This RE1 by Z, suppose this is the actual value and this is the base value of impedance, then RE1 by Z can be represented like R equivalent RE1 or simply R per unit cos phi 2 plus or minus X per unit sin phi 2. X per unit sin phi 2. This is another excellent equation for solving voltage regulation. And I represent plus or minus, right? This plus stands for if whenever you use plus means if the load is lag, and minus for load is lead. Lag load or load is lead for minus, and plus is for lag load and minus is for a lead load. And what is mean by lag load? If the load is inductive, more inductive in nature, or the voltage is lagging behind the current by some angle. Sorry, current is lagging behind the voltage by some angle. That's the meaning of lagging load. What is the leading load? It's a capacity load, because in the capacitor only current will be leading with respect to the voltage. So that is a capacity load. So this plus can be used in lagging and minus can be used in leading. Is it clear? Is it clear? Let's see next. Condition 4. condition 4, zero voltage regulation. Condition for zero voltage regulation. So we have the basic equation of voltage regulation as VR is equal to I1 into RE1 cos phi 2 plus or minus I1 into XE1 sin phi 2 all divided by V2 dash, right? For zero regulation to happen, that means the regulation value will be zero, right? That means I can write like for zero regulation this equal to 0, right? So 0 will be equal to I1 into RE1 cos phi 2 minus I1 into XE1 sin phi 2. Why I put a minus here? Because only in 0 equal to these are also 0. That is the meaning now. This is 0, LHS 0 means RHS also 0, right? If the RHS is 0, only possible when it is minus here. Suppose it is plus here, all the time that plus. If you add two quantities, there will be definitely add another quantity will arise, right? If you subtract one quantity from another only, there is a chance of 0, right? There is a chance of 0. So here is the chance of 0 happens only when this is in between minus. So definitely this will be the situation. So I can write like RE1 cos phi 2 equal to XE1 sin phi 2, or I can write like tan phi 2 equal to RE1 by XE1. Tan phi 2 is equal to RE1 by XE1. So this is the condition of zero voltage regulation. So whenever RE1 by XE1 equal to tan phi 2, at that time voltage regulation will be 0. What is that? Voltage regulation will be 0. So only possibility for zero voltage regulation is that the load is capacity. It's very important. It's a very important question. So only possibility for zero voltage regulation is the capacity load. Okay, this is very important. Please make it in a box. It will be directly asked in your examination. Is it clear? So that is the condition for what? Zero voltage regulation. Next we have to see condition for maximum voltage regulation. What is the condition for maximum voltage? See, the condition is very important. There will be a direct question from the condition itself. What is the condition for zero voltage regulation and what is the condition for maximum voltage regulation? That type of question will be asked. Okay, so let's see condition for maximum voltage regulation. Maximum voltage regulation. Again we have the same equation of VR equal to, what is that? I1 into RE1 cos phi 2 plus or minus I1 into XE1 sin phi 2 all divided by V2 dash. For maximum voltage regulation, what is the condition for maximum voltage regulation? D by d phi 2 of VR will be equal to what? 0. If you differentiate something with respect to the variable, if it gets 0, then we can say that there is a maximum change happened. So for finding the maximum of something, simply differentiate it, and with respect to 0, you will get some condition. That condition is the time at which that maximum happening or maximum process will happen, right? That is the meaning. So for maximum voltage regulation, because in the equation the parameter only variable is phi 2. Why phi 2 is variable? Because phi 2 is called the load power factor angle or load angle, depending upon the nature of the, because we are varying our load continuously, no? it is not necessary that all the time the load is what? Same. Because you are no, suppose in your take your home itself, our home itself, take it as example. All the time our lights are on, all the time our fans are on. No. Sometime depending upon the nature, we are on some fan, off some fans, on some lights, off some light, right? So the load is varying in our home during 24-hour time duration. In our home itself, this much variation of load is happening. Then regarding the power system, see how much variation of load will happen. So we can't say that the load is always a constant. So the load is varying means its load angle is varying. So the only variable here is nothing but phi 2. That is why d by d phi 2 of VR equal to 0. Let's do the differentiate, and that is nothing but d by d phi 2 of d by d phi 2. What is better? What is my dear? I1 RE1 cos phi 2 plus or minus I1 XE1 sin phi 2 by V2. By V2 equal to what? 0. Equal to what? 0. So definitely the answer will be what? Definitely the answer will be what? This I1 RE1 sin phi 2, right? Differentiation of cos phi 2 is another minus sin phi 2. Let's take plus for easy. So plus I1 into XE1 sin phi 2 differentiate means simply with cos phi 2 equal to 0, right? Equal to 0. Correct? Correct? Am I correct? Or I can say that RE1 minus RE1 sin phi 2 plus XE1 cos phi 2 equal to 0. Or I can write like RE1 sin phi 2 equal to minus XE1 cos phi 2. Minus and minus cancel here. We will get sin phi 2 by cos phi 2 equal to XE1 by RE1. Or I can say that tan phi 2 is equal to XE1 by RE1. So this is the condition for what? Maximum voltage regulation. This is the condition for what? Maximum voltage regulation in a system. Maximum voltage regulation in a system. Is it clear? Is it clear? Okay. And that's all for the theory session. Okay, let's do some problem so that we can apply the equation that we learned, right? We can apply the equation that we learned. Okay. Write a question. A transformer has, write a question, my dears. A transformer has 2% resistance drop. Resistance drop and 5% reactance drop. Reactance drop. Find its voltage regulation. Find its voltage regulation. VR means simply voltage regulation. Okay. At a full load. Full load 0.8 lag, 0.8 lead. How can we do this? How can we do this? There we seek the help of what? Per unit system. There we seek the help of per unit system. Let's do how it is. A transformer has 2% resistance drop and 5% reactant drops. Find the voltage relation as full load 0.8 lag and full load 0.8 lead bus. So we have the basic equation of VR as. What is the equation for VR now? I1 into RE1 cos phi 2 again plus or minus I1 into XE1 sin phi 2 whole divided by V2 dash, right? Whole divided by V2 dash. That is our equation. See, it is given that 2% resistance drop means I1 RE1 is the resistance drop. If it is mentioned as 2% drop means with respect to the terminal voltage 2% is happened as a loss. That is the meaning. With respect to this terminal voltage 2% happened as a loss in the resistor. That is the meaning of this sentence. Okay, that means this I1 RE1 divided by V2 dash cos phi 2 plus or minus I1 XE1 divided by V2 dash sin phi 2 plus. This is nothing but the given value of 2% and this is nothing but the given value of 5%. Okay, so it will become 2% means what is that? 0.02 cos phi 2. Cos phi 2 is nothing but what? 0.8 lag. So first you have to find for lag, right? Let's do it as a separate heading. Okay, then it will be very easy. That is 0.8 lag. First case is that 0.8 lag. So it will become VR is equal to, this is nothing but 2%, right? 0.0 into 0.8 lag. Power factor is nothing but 0.8. Since it is a lag means it will be plus. So 0.0 into 0.8 plus, this is nothing but 5.05%, right? 5% means 0.05 in terms of per unit. In terms of per unit, right? Or in terms of actual value, right? It will be 0.05 plus into sin phi 2. If cos phi 2 is 0.8, if cos phi 2 equal to 0.8, sin phi 2 will be equal to root of 1 minus cos square theta. Sin square theta plus cos square theta equal to 1. So sin square theta equal to 1 minus cos square theta square. It will be definitely 0.6. Fine, because it's a common value, no? It's a common value. You have to by heart this common value. If cos phi is 0.8, sin phi will be 0.6. Okay, so it will be 0.6. Right? Write the equation. It will become 0.02 into 0.8 will be 0.16. Correct? Plus 0.05 into 0.6 means, what is that? 0.05 into 0.6 means 0.03. So it will become 0.016, 0.019, correct? And percentage VR will be equal to, it is nothing but simply 0.019 into 100. So it is nothing but 1.9% plus 1.9%, right? Plus 1.9%. Okay, pardon me, the summation will become what simply, since I was overconfident in summation, that error happened, 0.016 plus 0.030, right? Correct. 0.046, right? And percentage VR will be equal to simply 4.6%. 4.6%. Is it clear? So that is for what? That is for what? That is for what? That is for 0.8 lag. Then that will be 0.8 lead. That will be 0.8 lead. It will become VR will be equal to 0.08 into 0.8 minus 0.05. Now change in only plus and minus will change, right? 0.6. Correct? It will become this is higher value and this is lower value, right? .024, right? Or percentage VR will be equal to 2.4%, right? 2.4%. It's fine. Correct? 10 minus 6 4, 2 minus 1 1, so 1.4, 0.014 or 1.4%. Am I correct? Okay. So that's all about the problem. See how easy if it is in what? Percentage, right? If it is in percentage. These type of question you may expect in your examination. Okay. And let's do one more problem. I think it's very clear to you, right? It's very clear to you. Write one more problems. See, feel the transformer and study. Feel it, everything you have to feel. If you feel and study, it will be very easy, it will not be very boring. Otherwise, it will be very boring and you will be easily forget. If you feel and study, it will persist for very long time. In your mind. Calculate the regulation of a transformer. Calculate the regulation of a transformer in which ohmic losses is 1% and reactance drop is 5%. 5%. Calculate regulation when power factor is, it's already there, comma, when power factor is A 0.8 lag, B 0.8 lead, and C unity. How can we do this? How can we do this? Do you have any idea? See how beautiful the problem is. Simple is right. Let's do that. So the voltage regulation equation is, again we have to write that equation, that I1 into RE1 cos phi 2 by V2 dash plus or minus I1 into XE1 by V2 dash into sin phi 2. Correct? It is given that the ohmic loss is 1%. Ohmic loss is nothing but what? This one. Ohmic loss with respect to V2 dash is nothing but 1%, right? So this is 1%. This parameter is 1%. And the reactance is 5%, right? Reactance losses is 5%. So this is 5%. Simple. How simple it is. So 0.8 for, let's do first for 0.8 lag. So it will become VR is equal to 1% means it will be 0.01 into 0.8 plus 5% means 0.05 into 0.6. So the answer will be 0.01 into 0.8 means what? 0.008, correct? And plus 0.05 into 0.6 means 0.03, correct? Correct. So it will become, what is the answer? Let's do this because I have already, see, 0.03, 0.008, right? So 0.038, correct? 0.038. So the answer will be what? And in the previous problem, no, that answer contain a minus signal. In the previous problem, right, first one minus second one, no, there is a minus sign that you have to put, okay, that you have to put, there is a minus sign because it's a capacity load, okay. So come to this problem, 0.038, it is nothing but VR. So what is the percentage VR? What is the percentage VR? Simply multiply it with 100, it will become 3.8%. That is the answer. And next condition is nothing but 0.8 lead. 0.8 lead. What will be VR now? What will be VR now? It is nothing but 0.01 into 0.8 minus 0.05 into 0.6. It will become 0.008 minus 0.030. Subtract if it is, definitely there will be minus that you already put, and 0.03 minus 0.008. Okay. So 0.008 minus 0.30, what will be the answer? It will be 0.022, correct? 0.022, am I correct? 0.022, right? Am I correct? Yes. So the percentage voltage regulation will be equal to minus 2.2, correct? Minus 2.2%. So this is the final answer, minus 2.2%. And what is the next case? Next is nothing but UPF. UPF means cos phi 2 equal to 1 and phi 2 is nothing but 0 degree, and sin phi 2 is nothing but what? 0. So voltage regulation is nothing but simply I1 into RE1 cos phi 2 by V2 dash only, because the next term is sin, that will be 0, no need, right? So it is given, these parameters given as what? What is that? 1%, right? So 1%, that is 0.01, right? 0.01. It is 1%, right? 0.01, correct? 0.01 into cos phi, it is nothing but 1. Cos phi is nothing but 0. So answer will be 0.01. Percentage voltage relation will be 1%. Percentage voltage relation will be 1%. How is the problem? How is the problem? How is the problem, ideas? Did you get the idea? If you do this problem, means it's very easy. If you are in what per unit or percentage quantity, you will feel the difference. Okay? Okay. And please be active. Okay, this is my family. I consider this my family. So please be active. You can discuss something. No, you can comment something. You can discuss here. If I put some shorts and all, you please actively participate. No, we learn with interest, right? Let's learn with interest and idea, full concept. Not simply mug up, right? Simply don't mug up anything. Please, study with idea. Then only it will be interesting. You will feel like I'm living. If you simply mug up means, oh my God, I'm going to die, because you are taking too much, right? Too much load, right? And simply, but you are eating something after you feel, I mean, you what? Completely remove your hungry. Even if you don't feel any hungry, you again and again eat means that is the what meaning of that mug up exactly. But if you really feel and study means you enjoy and eat, bas. Right? You eat with enjoyment. That is the feeling. That is the difference. Okay. So please always, actually it's a bad joke, I know. It's a bad joke, I know. Okay. Simply I did some example. Okay. I want to just convey the idea only. Okay. And don't think about the joke, and it's a bad joke, I know that. Okay. Pardon me. So let's do another problem, right? A transformer has a resistance of 2% and reactance of 4%. Resistance of 2% and reactance of percentage resistance, right? Percentage resistance of 2% and percentage reactance of 4%. What are its regulation at? What are its regulation at? A. 0.8 lag. B. 0.8 lead. And C. Bus lag and lead only. 0.8 lag and lead only. Bus. 0.8 lag and 0.8 lead only. How can we do this? How can we do this? First thing, always please write an equation for voltage regulation. I1 into RE1 cos phi 2 by V2 dash plus or minus, what is that? I1 into XE1 sin phi 2 by V2 dash. Okay, first you have to write this equation. Then you have to look the question. A transformer has a percentage resistance of 2%. Percentage resistance means what? This is nothing but RE1 divided by V2 dash by I1 cos phi 2 plus or minus XE1 divided by V2 dash by I1 into sin phi 2. That is the meaning. So it will become, that is VR. So VR become percentage resistance means RE1 by V2 dash by I1. Already told you. This is nothing but Z. RE1 by Z will be the percentage resistance. Percentage resistance. So it will be equal to per unit resistance plus into cos phi plus or minus per unit reactance sin phi 2. Bus. So it will become per unit resistance is given, that is a 2%, right? So 0.02 into 0.8 plus first one 0.8 lag, okay? 0.8 lag, okay? I will write it. So this is a general equation, right? So 0.8 lag will be BR is equal to, what is that? Per unit resistance is given 2%, right? So 0.02 into 0.8 plus 0.4% is the resistance, so 0.04 into 0.6. Simply it will become 0.016 plus 0.024, correct? So what will be the answer? 0.016, 0.024, 0.040. Am I right? So that is VR, or percentage VR will be equal to 4%. So that is the answer. That is the answer. And what is for 0.8 lead? What is the 0.8 lead? VR is equal to 0.8 lead means it will be 0.02 into 0.8 minus 0.04 into 0.6, which is nothing but 0.16 minus 0.024. 0.6 plus 8, right? So it will be 0.008. Am I correct? Am I correct? So the answer will be percentage VR will be equal to what? This is simply multiplied to the 100, so minus 0.8 percentage. Minus 0.8%. So super system, right? Percentage relation is very less. If the percentage voltage relation is very low, means the system is that much superb. The system is that much superb. Okay? Did you get the idea? Did you get the idea? Can you do any problem in percentage now, right? Can you do any problem with respect to this percentage concept, right? That was my aim. That was my aim. That's why I continuously doing the same type of problem, because you have to fix your mind towards this equation, That is my aim, okay? Okay, write another question. A single phase transformer have no load. Has no load. No load voltage is 1.2 per unit. 1.2 per unit, and find the voltage regulation. Then find the voltage regulation. Then find the voltage regulation. How can we use tricky equation here? A single phase transformer has a no load voltage is 1 point per unit. So you should always bring the equation to your mind that VR is equal to another equation is what is that? Per unit voltage minus 1 bus. That is the equation, voltage relation equation. So it will be simply what? 1.2 minus 1.2. Percentage VR will be equal to 0.2 in 100 means 20%. How simple the problem is. If you know the basic, if you know the concept, if you fail the subject, it will be how much easy problem is. How much easy the problem is. That is the difference. So feel and study. Again saying, feel and study, my dear. Yes, feel and study. Okay? Is it clear? Okay. And let's move to another session. So that's all about this voltage regulation. It's very easy actually. You can score any problem. You can score full here, because more than this, for RRB JE and SSC JE level or all state A JE level, more than this will not be asked. I hope so. And let's do another section. Losses in a transformer. Losses in a transformer. So losses are classified actually. There are two main losses in a transformer. First one is core loss or iron loss. Second one is copper loss or ohmic loss. Copper loss or ohmic loss. Let's focus on this core loss or iron loss first. Core loss or iron loss first. First we have to see this core loss, iron loss have again two types of loss are here. Eddy current loss and hysteresis loss. Eddy current loss and hysteresis loss. Let's see one by one. First one, eddy current loss. See, The core loss or iron loss or constant loss, in other words, it's a constant loss. It termed as, or how it is arises, it is due to the material. It is due to the nature of the material. I mean, characteristics of the material. Material in the sense, I will say one by one. First, you have to see eddy current loss. What is eddy current loss? It is represented by the term PE. It is represented by capital letter P, small letter E, PE. The eddy current loss, the meaning of eddy current loss is that, see, the transformer's core is made up of this light. This means this so many laminations are there, right? So many laminations are there, right? So on which we wound some coils, right? So whenever we sending some current to the coil, there is a magnetic field associated with the coil, varies if we apply the sinusoidal signal. If we apply some sinusoidal signal, definitely that current will be changing accordingly, according to the nature of the signal, it will change. So there is a change in magnetic field, and the core is situating in a changing magnetic field. So there is a possibility of, since the core is a closed path, my dears, since the core is a closed path, there is a chance of producing some voltage induced on the cores. That is called the eddy current. I mean, due to that EMF, there is a circulating current on the surface of the core. If there is a current through any conductor, means the core is also made up of some conductor, right? So there will be definitely a small amount of heat dissipate. So that heat dissipation is called as the eddy current loss. So how can we reduce the eddy current loss? To reduce this eddy current loss, we are using laminations. Lamination is nothing but, instead of making a thick core, we have to slice the core by so many, so many light sheets. That means its area will be very low. Area of cross section will be very low. If the area of cross section is very low, means R equal to what, my dears? Rho L by A. If A is very less, means R will be very high. That means the eddy current will feel very difficulty when it is flow through the core. That means there will be less heat loss due to eddy current, because it feels very difficulty when it is flowing through the surface of the core, because R is very high. If we make the sheet sheets like small sheet, and each sheet is laminated on both sides and punched together or bunched together. So by looking, it will feel like a massive core, but closely observing, it is made up of small sheets, so that the area will be very less. Suppose you are using a hard core, what a very big core means, its area of cross section, if area of cross section is very high, so that R will be very low, so that eddy current will be very high. Eddy current can easily flow, so I square R will be very, very high there. Heat loss is nothing but I square R. But now, since R is very low in sheets, you take a small sheet, the area of cross section is very less here, very small there. So what will be A? It is very low. If R is low, means eddy current will be very, very low. Sorry, R is high, means eddy current will be very, very. That means I square R will be very, very low. That is the usage of making lamination in a transformer. That's all about the eddy current. And there is an equation for eddy current loss, which is nothing but some constant K into B max square into F square into T square into V, where K is a constant, B max is the maximum flux density, F is nothing but the frequency, T is nothing but the thickness of sheet, V is nothing but the volume of sheet, or volume of simply core, volume of core. So that is the equation for what? Eddy current loss. this much watts, my dears, or joule per second. The another unit of watt is nothing but joule per second. How to come? Power is equal to work done by time, joule per second. Unit of, I mean, P, right? Power, right? Power equation. Eddy current loss, right? So that was watt, correct? That much watt. Yes, correct. Correct. So this is the equation for power loss due to eddy current, right? Power loss due to, again, PE means power loss due to eddy current. Next we have to see hysteresis loss. It is represented by pH. Hysteresis loss is arranged by, I mean, it is arranged due to the molecular structure of the magnetic material. That means it is deep concept actually. I will tell you very shortly. There is a dipole moments in the magnetic field, right? There is a dipoles in the magnetic material. There is a dipole in the magnetic material. That means it is actually the net dipole moment is zero. If we not applying any magnetic field, the net dipole moment is zero. That means equal positive and equal negative. If you apply some magnetic field, it is arranged in same manner. It is arranged in same manner. If you apply the reverse magnetic field, it is arranged in opposite manner but in same pattern. If the frequency is increasing, this material doesn't get enough time for this reversal. That means there is a material, I mean there is a dipole which doesn't have the capacity to rotate as fast of the frequency. So that will remain there. And that produces a heat. That produces a heat or loss from the applied power. It consumes an energy. If you consume energy and do some work means it is good, right? So if you consume energy and you are rigid and you are not doing anything means it is as loss. It is a loss actually. It is a simplest explanation actually. The explanation is very big and very deep actually, but it is a simple explanation for the hysteresis loss. So it is associated with the magnetic material, right? Magnetic dipole and magnetic material. So for reducing that hysteresis loss, we are using silicon steel lamination or lamination, not silicon steel. That means the silicon has an excellent property of a good magnetic material. So the silicon steel will reduce what? Silicon steel will reduce the hysteresis loss. Silicon steel will reduce the hysteresis loss, or in other words, it having a very less BH curve. Very less BH curve. The area of the BH curve of silicon steel is very low. The area of the BH curve representing the the hysteresis loss. Okay, so it's actually we will study it in a separate session. Okay, just for now I just gave an introduction. Okay, so there is an equation for this hysteresis loss also due to the imperfection in the magnetic material, due to the imperfection in the core magnetic material. There will be the loss, or the hysteresis loss can be write by pH is equal to some constant, again some constant, into B max raised to x into f and v. F and v. kh into f into B max raised to x into v. Okay, where again f is the frequency and v is the volume. Volume is the volume of sheet, right? Volume of sheet is the volume of sheet. Or That's all. Okay. So that is the equation, and the value of x will be equal to 1 to 2. The range of x will be 1 to 2. 1 to 2. Okay. And we will slightly modify our equation so that we learn something from that also. We will do what it is. We will do what it is. So we have eddy current equation is nothing but k into f square b max square t square into v, right? T square into v, right? In a transformer, we have an equation of EMF induced in a transformer. Suppose it is V1, which is nothing but E1, which is nearly equal to E1. Because in a transformer, the applied voltage will be definitely a small portion of the voltage is as a drop in the primary winding, and the remaining will be what? Back EMF. Did you get that idea? Definitely there will be some drop, right? So this is E and this is V. If a drop is very small here, so definitely E and V will be same nearly. So we can write V1 nearly equal to E1. So V1 will be equal to, what is the equation? What is the equation for V1? Which is nothing but 4.44 into F of m into what? N1. Correct? F1 in the case of primary. So what is m here? I can write like 4.44 into F into B max into A. Can I write this? Because B is equal to 5 by A, so what 5m will be B max into A into N1. Am I correct, beta? Am I correct, my dear? So I can write like this B max can be write like V1 by 4.44 into F into A into N1 will be equal to B max. Substitute this B max in this here, this equation. What I get? So PE will be equal to K into F square into B max is nothing but B1 square divided by 4.44 F square A square N1 square, right? So into T square into V. This V is nothing but volume. So this V square, this F square and F square get cancelled. So I can write like PE proportional to V1 square bus. PE proportional to V1 square, because area is constant, number of turns is constant, thickness is constant, volume is constant, K is already constant. So PE directly proportional to V1 square. That is the eddy current loss is directly proportional to the square of the applied voltage. Very, very important relation. Very, very important relation. Eddy current loss is proportional to the applied voltage square. Applied voltage square. This equation or the relation you can use for many, what problems, for many problems. Okay. And we have PH is equal to some constant KH into F into Bm raised to X into, right? Bm raised to X into V, correct? Bm raised to X into V, am I right? Yes. So again this Bm raised to X can be right like KH into F into, what is this Bm? We found that Bm, right? It is nothing but V1 divided by 4.44 into F into A into N1, correct? Whole raised to X into V. This V is thickness, volume. So the relationship become, listen very carefully, listen very, very carefully. Listen very carefully. So pH will become this F, my dears, this F and got that F raised to X top side, so it will become, can I write like this, Vn raised to X into F raised to 1 minus X. Am I correct? Am I correct? So pH will be proportional to V1 raised to X into F raised to, already 1 is there, F raised to X minus X, so F raised to 1 minus. These two relation, my dears, it's very, very useful for solving problems, okay? For solving problem. Am I clear? Is it clear to you? What's the time now? Okay, let's wind up for today. Let's meet again tomorrow, okay? Until then, thank you.